Question number 21. A ball is projected horizontally with speed u and a ball A is dropped vertically from rest at the same instant as shown in the figure. Which of the following statements is true? Neglect the air resistance. Question number 21. There is a diagram like this. The ball A is dropped vertically and ball B is projected horizontally with a speed v. First statement, A reaches the ground first and a higher speed than B. No, when considering vertical motion, for both objects, the vertical initial velocity is 0 and there is the same acceleration. Therefore, both objects reaches the ground at the same time. There is the same time for the projectile motion. Then first one is incorrect. Second statement, B reaches the ground first with a higher speed than A. It also incorrect because of we have to get time is common for both objects. Then third statement, A reaches the ground first. It also incorrect. Fourth one, both A and B reach the ground at the same instant with the same speed. Both A and B reach the ground at the same time, but final velocity of B should be greater than A because of we know that there is a final vertical velocity for A and B. I will consider it as V1. There is a common final vertical velocity, but for the motion of B, there is a horizontal velocity. Therefore, we have to get resultant velocity of B as the final speed. Therefore, final speed of B should be greater than A. Then fifth statement, both A and B reach the ground at the same instant, but B with high speed than A. It is the correct statement. Then fifth answer is the correct answer for question number 21. Question number 22. Figure shows displacement versus time curve for the motion of a particle. Consider the following statements made about its motion. They have given ST graph, not VT graph. Displacement time graph. Then statement A. During the period T0 to T1, particle moves at a constant acceleration. No, it is false. They have given displacement time graph. We know that gradient of displacement time graph is velocity. Therefore, there is a constant gradient. This part has a constant velocity, T0 to T1. Then first statement is false. B. Particle comes to rest at time t4. It also incorrect because of at this place there is a gradient. From this point to this point there is a gradient. It means there is a velocity in minus direction because of this is a minus gradient. If the object is at rest, gradient should be 0, graph should be like this part. Then it is false. Then statement C. During the time period T0 to T4, the total distance traveled by the particle is equal to the area under the ST curve. It also incorrect. We know that total distance traveled by the particle is this distance. We can get value of y-axis for this part, and we have to add this distance to the object. But we know that this distance equals to this one, and there are opposite directions. Therefore, displacement of the object should be 0. Then statement C also incorrect. All A, B, C false. This one is the answer for question number 22. We can remember ST, VT, AT. There are three types of graphs: displacement time, velocity time, and acceleration time. We know that gradient of displacement time graph, gradient, should be equal to the velocity, and gradient of velocity time graph is representing acceleration. And area of AT graph, area of acceleration time graph representing velocity, area of velocity time graph representing displacement. Then question number 23. A person simultaneously drops an object and throws another object vertically downward from a certain height. Which of the following graphs best represents the velocity time curve for two objects? Curve A represents the dropped object and curve B represents the thrown object. We know that there is a same acceleration for both objects. I will consider first object and second object. First object is a motion under the gravity, and second object also is a motion under the gravity. Therefore, both objects has an same acceleration. We know that acceleration is gravitational acceleration g. But when considering second object, it has an initial velocity. Initial velocity of first object is 0. Therefore, we know that gradient of velocity time graph is representing acceleration. Therefore, both objects has the same acceleration. Therefore, we have to draw graphs with same gradient. But for the second object, there is an initial velocity. Therefore, initial velocity should be greater than first object. Then we can get velocity time graph. Correct answer is first answer for the question number 23. Then question number 24. Velocity time curve for the motion of particles shown in the figure. The corresponding displacement time curve would be given velocity time graph is like this. For the first part, this part, there is a minus gradient. It means velocity decreases. Velocity decreases. Therefore, we know that this gradient of displacement time graph is representing velocity. Velocity should be decreased for the first part. Then gradient of ST graph is decreasing like this. Gradient means this angle with positive x-axis and graph. It is decreasing from this point to this point. And for this part, velocity is 0. Therefore, gradient should be 0. There is a parallel part to the x-axis, time axis. And then velocity increasing. Velocity is increasing. Therefore, we have to show the graph like this. Gradient should be increased for the second part. Then we can get corresponding ST graph is this one. This answer is the correct answer for question number 24. Question number 25. Photographs of an object start falling freely from at rest at t equals 0 are taken by a camera. First at t equals 0 and thereafter at the end of each second, which of the following diagram correctly indicates the location of object at the end of each second? The vertical axis of the diagram represents the distance traveled by the object. We know that when considering a free-falling object, for the first second, t equals 0 to t equals 1 second, displacement should be 5 meters. We have studied in theory part. Then for the second, we know that displacement should be 15 meters. For the third second, displacement should be 25 meters. Then we can get first one is incorrect. First second 5 meters, but second it is not 15. 5 past 15 should be 20. They have represented correct graph in fourth answer. For the first second 5 meters, after the second displacement is 20. It means displacement for the second 1 second time period is 15 meters. 5 plus 15, 20. Then fourth answer is the correct answer for the question number 25. If you can't remember that theory part, you can calculate. We know that initial velocity 0, final velocity for first second 10 meters per second. Then we can use st equals u plus v over 2 times t for this 1 second time period. Then initial velocity 0, final velocity 10 divided by 2 times time 1, 5 meters. And for the second 1 second time period, we can use this method to calculate 15 meters displacement. Then question number 26. The variation of velocity with time of a particle is shown in the figure. The corresponding displacement time curve is best represented by. For the first part of velocity time curve, it is like this. Velocity time. We can use displacement time graph. We can make displacement time graph with same time axis. For the first part, velocity is increasing. It means gradient of displacement time graph should be increased for the first part. Gradient is increasing. Then it should be like this. And for the second part, there is a constant velocity. Then gradient should be constant. Gradient increasing, it means angle increasing, and gradient constant. Same gradient. This one is a linear part. And then velocity decreasing and becomes 0 at this place. Therefore, gradient should be decreasing and gradient should be 0 at this place. It means for this point, graph is parallel to t-axis. And velocity is increasing in opposite direction for this part. Therefore, velocity increasing, therefore gradient should be increased for this part, and it is in opposite direction. Therefore, displacement should be decreasing. It means we have to get the graph should be turned back. And final part, its velocity again decreasing, minus velocity decreasing. It means gradient should be decreased for this part, like this. Angle should decrease for last part. Then this one is the correct answer for question number 26. Then question number 27. An object is projected under gravity with velocity v in the direction which makes an angle theta with the horizontal as shown in the figure. Which of the following graphs correctly indicate the variation of horizontal and vertical components of the velocity of the object with time? We know that horizontal velocity component is constant for the motion. Horizontal velocity component should be constant for the motion because of acceleration due to gravity is in downward direction. There is no acceleration in horizontal direction. But when considering vertical velocity, we know that from this point to this point, velocity is decreasing and velocity at the highest point should be 0. Vertical velocity at the highest point is 0. Therefore, vertical velocity should be like this. And for this part, velocity is in opposite direction. For this part, vertical velocity in upward direction. For this part, vertical velocity in downward direction, and it is increasing. Therefore, velocity should be like this. Then we can get corresponding graph is, this is vertical velocity. Then corresponding graph is this one. This one is the answer for question number 27. Question number 28. A ball is dropped from a height of 1.8 meters into a rigid surface. The collision between the ball and the surface is perfectly elastic. If the ball continues to bounce the surface, the motion of the ball is. We have to consider the motion of the ball and period. We know that when considering time taken to collide in with this surface, distance 1.8 meters, initial velocity 0, the ball is dropped from a height of 1.8 meters. Then we can find time taken to the motion. We can use s equals ut plus half at squared. S is the displacement 1.8. Initial velocity is 0, therefore ut term is 0. Half acceleration 10, it is under the gravity, t squared. 2 divided by 2, 1, 5. 1.8 divided by 5. 1 divided by 5, 0. 18 divided by 5, 3, 6. T squared. Then time taken to collide in with horizontal surface is 0.6 seconds. It is a fully elastic collision. It means there is no a kinetic energy loss. Therefore, it should move in upward direction again 1.8 meters height. Again to 1.8 meters height with same time peak. Therefore, for this motion, total period is 1.2 seconds, 2 times of this one. Period is correct in first and third answers. But we can consider, we can remember simple harmonic motion. For the simple harmonic motion, the force and acceleration towards the oscillating center, to like this way, towards the oscillation center. But for this motion, force is in this direction for the whole motion, downward direction. Therefore, we can't get it as a simple harmonic motion. We are using A equals minus omega squared x to define a simple harmonic motion. According to this equation, acceleration should be in the direction of center of oscillating, and acceleration should be increasing with the displacement. Acceleration directly proportional to displacement. But when considering this motion, acceleration is only in downward direction for the whole motion. Therefore, we can't get it as a simple harmonic motion. Then not a simple harmonic motion, but periodic with period 1.2 seconds. Then third answer is correct answer for the question number 28. Question number 29. If a velocity of an object varies with time, t as shown in the figure, the corresponding variation of the displacement with time is best represented by. I will draw the velocity time graph and corresponding displacement time graph. Velocity time graph and displacement time graph. For the first part of the motion, velocity is a constant value. It is not increasing or decreasing. Therefore, gradient of the displacement time graph should be a plus constant value like this. And for the second part of the motion, velocity, this part, velocity is decreasing to 0. Then gradient should be displacement time graph decrease with time, and gradient should be 0 at this place. It means for this point, graph should be parallel to t-axis. And this part, third part of the motion, velocity is in opposite direction and increasing. Displacement in opposite direction and increasing. It means velocity increases. It means gradient should be increased for this part. And for the last part, velocity is a minus value. Then displacement has a constant minus gradient. This is a straight line with constant minus gradient. Then we can get second answer is, no, first answer is the correct answer for question number 29. The difference between first and third answers are, first and second answers are, in second answer, this part is not a linear part. First answer, this part and this part are linear graphs. Therefore, we can get first answer for the question number 29.